refraction through a glass slab. Here, this is a glass slab and light ray enters from air to glass, then finally emerges out, that is from glass to air. It means refraction takes place two times. When light ray enters, this is your incident ray, from air to glass, then rarer to denser medium it's coming. That's why light ray bends towards the normal, and this broken line is the normal. Again, this refracted ray becomes incident ray for glass and air medium. Now, when finally it emerges from glass to air, then it's coming from denser to rarer medium. That's why it bends away from the normal. This is your normal, it bends away from the normal. Now, as you know, this is your angle of emergence. This is your angle of emergence. This is your angle of incidence. And this is angle of refraction R. And this is I dash, we have written angle of incidence for glass and air media, for that pair. And we are going to see angle of incidence is exactly equal to angle of emergence. Or in other way you can say, in original incident ray, this you can say original incident ray parallel to the final emergent ray. So when you can say this, if angle of incidence is equal to angle of emergence, that's I equals to E. Now how to verify this? Just applying Snell's law you can verify this. You have to apply Snell's law at 2 points. For air to glass media, at this point you apply Snell's law. Second, from glass to air, when light ray coming out from glass to air, then at this point P you apply Snell's law. Let us see. So at first, at N, using Snell's law, what you will get? Sin I over sin R. Here I is the angle of incidence, R is the angle of refraction. That is your refractive index of what? Glass, because light enters from air to glass. The refractive index of glass with respect to air. This is suppose number 1. And at P, at this point, let us apply Snell's law. Then in this case, this is your incident ray. Actually, this is refracted ray for air and glass medium. But if we consider glass and air medium, then this is your incident ray. And this is your refracted ray. That's why their sign of angle of incidence I dash, by I dash we have denoted. This is your I dash divided by sign of angle of refraction. So here is the angle of refraction, which is known as angle of emergence. Angle of emergence is nothing but the angle of refraction only. Okay, this is equal to refractive index of what? Refractive index of what? Refraction takes place in which medium? Air medium. So that's why you can say refractive index of air with respect to glass. This is your number 2. Now, simple, multiply 1 and 2. 1 into 2. You will get sin I by sin R multiplied by sin I dash by sin of E equals to NGA, refractive index of glass with respect to air, into refractive index of air with respect to glass. This much we will get. Now come here, simple geometry we have to apply. See, actually this is a glass slab like this. This is a glass slab. And this broken line is the normal at this. And this is also normal at this surface. But in the board we have to draw like this way. So that's why this is a glass slab, this is perpendicular to this is perpendicular to this. I mean to say, in that case you see, this and this are parallel to each other. Now consider this transversal. So here R is exactly equal to I dash. R is equal to I dash. Why? They are interior alternate angles. Simple geometry. So as R is equal to I dash, so you do one thing, implies sin I as it is by sin R, we can write sin of I dash into, it is as it is sin of I dash by sin of E equal to, now say refractive index of glass with respect to air, if you take the reciprocal of this, that will be your what? refractive index of air with respect to glass. So it is 1 over refractive index of air with respect to glass into refractive index of air with respect to glass as it is. This refractive index of glass with respect to air, and if you take the reciprocal, 1 over refractive index of air with respect to glass into refractive index of air with respect to glass. So this two will be cancelled out, and here what you will get, sin I dash cancel out. So sin I over sin E equal to what? 1. So finally sin I equal to sin E implies I is equal to E. So I is what? I is your angle of incidence and E is your angle of emergence. So from here, mathematically you have proved that angle of incidence exactly equal to angle of emergence. It means original incident ray parallel to the final emergent ray.